everybody. So I'm very thankful for all the feedback that you are giving. From the first day's feedback, I learned certain things that I should change. So I will try to provide you more time for hands-on a little bit. So please keep on giving feedback on the HackMD. So if you see something missing, or that I should go slower or faster or more time for certain things. So we'll start with a session on containers, and then we will go. Okay, let me focus that first material here. We'll do that for about 1 hour, and then we go to the NIR toolkit. Siri will come and take that session. There are 2 sessions, and at the end we'll have some question and answers. But for your question answers, this HackMD, the link that somebody will paste now on the Zoom chat if you don't have it already. So this is the place for your questions, not the Zoom chat. The reason is, when you ask these questions, there are many people who can I think answer answer immediately, or maybe answer later, and this document goes to an archive. So this will be there for you to check back later on. So to start with, so we have this question. Okay, so I guess you know how to edit the HackMD. So if not, let us know. I will show you. So this, on this document, you can edit it, and there's a question about the use case for containers. Why you should, why we need to, why we might need to use containers in certain situations. So please type in what you think, so we can have some background to what we are going to talk about. So the first thing I see there is that there's a software stack or a pipeline already set up somewhere else, and you want to bring it as it is to from. Okay, so it could be from Saga or Betsy. So it is something to bring all the pieces as it is to somewhere else and run it. Yes, that's a good use case. Yes, so to be able to use various versions of the program, independent projects. Yes, so we have the module system on Saga, if you remember. So we can have different versions of Python, different versions of R, different versions of GCC, different versions of other compilers. But there might be cases where you don't find this version that you're looking for. There might be a program that runs on a very specific version. There might be a very specific version of a program which runs on a very specific version of operating system, for example. On our HPC systems, we run this operating system called CentOS. But maybe your software, that version only runs on Ubuntu 14.4, for example. So then we can't change the operating system. Or maybe there's an old module, or maybe very new module which is not available as a module that you want to bring in yourself. It's a very good point, the second point. Yes, so if your system needs to install things, if the procedure, or if the developer mentions the procedure and it involves apt-get install or yum install or RPM install, then that you can't do on the HPC system, because you don't have root privileges. Like normal users, like even me, when I log in as my user account, logging with my username, I don't get to do these things. The reason is, if everybody going to change these things, it's going to be a little messy. So there's a procedure for that. This is actually a even better mention, I think. Not quite sure what is meant by a container, right? So that's going to make me start little like in a OO level when I start. Thank you very much for that question. You want to use it in order to combine several codes without having to worry about compatibility, so setting up joint environments, the idea is to follow for scalable code environment where we can combine containers with native builds. That comment I'm not quite like let me try to comprehend that. Okay, so it is to combine different pieces in one package, if I understand correctly. Please correct if I was wrong. Without, yes, so so what I see from this one is that we're going to combine different disparate pieces as a single unit. Wouldn't it be needed if software installation would be fully portable? Very good point. Abdurrahman, are you available on mic?
Yes, I'm here.
Yes. So the last time, as you know, Abdurrahman, I'm not a fan of containers. Abdurrahman is sort of the container guy, so go to guy in these cases, and you are doing some work on Lumi as well. So the reason, Abdurrahman, that I'm going to talk about today is, although if I'm not a fan of containers, there are certain situations that you have to use containers. So if the code is portable in that sense, that if you can compile in any system, then I don't see a point of containers. But even that, people might have a case for that. So thank you for this.
I can I can elaborate a bit about this. So if when you say if the software installations would be fully portable, it means that there is a recipe for installing the software on Red Hat, for example, on SUSE Linux, on Debian, on Ubuntu. So the vendor of the software needs to provide these recipes. If you will use Easy Build, for example, you need to have the recipe, and the recipe that works for Debian doesn't work for CentOS. The advantage of container in this case is that you need to build it once. You build it for Debian, and then it will work for other Linux distributions. But it's important to take into account that containers abstract whatever above the kernel, not the kernel, not anything below the kernel. It means that if you have some specific drivers, like GPU, like InfiniBand, Slingshot for network, or specific architectures of CPUs and GPUs, you need to have these in the container installed, because if you run it on a specific architecture, it will not certainly run in the same way in other architectures. Sometimes it can provide errors because it doesn't have the drivers, or if you run it on a specific CPU architecture and run it on another CPU from the same family but not the same version, you will not get the same efficiency because it was compiled for this processor, not the other one. So these things has to be taken into account when you run it on expensive HPC systems like the ones that we have on Sigma 2 or Lumi, for example. But whatever above the kernel can be abstracted. Sometimes the kernel also is a can be a showstopper. Sometimes for some applications, if you compile them for modern kernels, it will not run on your kernel. But these are specific cases. Yeah.
So thank you, Abdurrahman, on that. So what I'm going to talk today is that you are forced to use a container, not that you have the option of a code that compiles. So as I mentioned before, I'm not a fan of containers. I'm going to look at a pessimistic view of it, and I'm going to look at it in a user perspective. That you land in one of our HPC systems, you don't have root password or like magic access or like extra privileges, but there you have this software that not installed on a HPC system. You can't compile it, so you are forced to use. So I will be sort of focusing on that track, that what are the basic know-how you need in order to do that. I will not go into very deep, like not very deep. I'm not going to go into any details about how the containers are structured, how you create containers, how you modify containers, etc., etc. I'm not going to do, because that you can't do on our systems. So I'm going to show only the things you can do. But there's a slightly advanced lecture tomorrow that might touch upon slightly more things. So yes, so this is open source and license based as a code mixture. So there are companies that I know, that bioinformatics companies, for example, or like pharmaceutical companies, they have this software stack. It's always on a Docker, so it's or some sort of container that they use. So it's always confined to certain build. So they build the container itself without trying to produce an installation procedure. Yeah, I also use them on my own computer to encapsulate document software installation, which is only needed once a year without polluting my operating system. Yes, so there's something that you don't want to go system wide. Let's say like there's a software, like let's say Python 2, like you need Python 2 environment, and you just don't want it once, and you don't want to install it on your system wide, and then you can use this container to have it once. Strange starts if you are skeptic. Strange start. Being skeptic is personal view. You are very good. So the let's say so a skeptic or a person who's like not a big fan of containers is a best person to present what I'm presenting today, in my opinion. We might have a short discussion with Abdurrahman later, maybe. The thing is, if I'm like a fan, if I'm going to present as the container as like a holy grail, the solution for everything, any problem, get a container. You have this problem A, problem C, problem D, get a container. And if I say that, that's going to be not close to the truth. So and it will not open up more discussion. So let's have it as a session of discussion. Okay, let's work well. Yes. Okay. So I'll go back to the lesson now. I guess you can read this well. If the text site is not that, if it is too small, let us know. So what is a container? So there was a question that there might be people who has heard of containers, but they don't know much detail about it. So we could get a very detailed structure of container, how they are built, how the container runs on top of a operating system, not like a virtual machine. Like, it doesn't have all the components, but it uses the operating systems, something called a kernel. That is the basic part of any system. A kernel is something tells the system how to behave to a user response, or maybe a system response. That the behavior is defined by that. So container is more or less like a shipping container. Like, everything is inside that you need. So if you load a module, for example, on our system, let's say module load Python 3 3.8110 GCC 10.03, that will modify your path in order to get Python. But the underlying operating system is always CentOS 7, which runs on our system. So you could think of a container as a thing which encapsulate all the cargo needed for the software to work. The operating system, the libraries, the packages, everything. So you have it, and then you run it. We'll try to understand a little bit more about it through certain examples. So there's some disclaimer here. We are showing how to use existing container images, containers that already been made by somebody. A developer is distributing the container as his or her software as a container. It's not about building your own containers or modifying them. It is not discussed, but we'll give a detail link to a video on the HackMD that talks about these sort of concepts. how you build a container, for example. But today's focus, it's not that you have some container there that you won't run on the HPC. So when to use a container? So this document is under development, this part. So from the HackMD, we will try to get more things here as well. So if you have more notes, more suggestions to improve this document, please paste that. So more or less, these things we have already talked about. So this is also that recommendation. That's so sort of it's I think part technical, part political, right? So these are some views when not to use container. So we would prefer if you have already a module, a set of modules that you could actually use, then no point of having container. But you might make a case that you need a container, but it's not the first thing you should know. If you have the module, use it. Windows containers would not run. So there was some request some time to time. There was this Windows software that somebody want to run it. So because then they were given the wrong impression about containers, about saying, okay, you have this container means something that could run on any system anywhere. So that's not the case. Windows containers will not run, but because of our system is more or less, we call it the x86, the AMD, Intel, that sort of architecture. It's a very common architecture. So most of the containers would not stop at that boundary. We have some machines in IBM machines, for example, in University of Oslo, which certain containers would not run. So that not all containers are fully portable. So that's a wrong thing. And if you don't know what it does, so you browse the internet for searching something, let's say to find a solution, and you randomly encounter a command that has container commands in it. You want to copy paste it without knowing anything what it does. It's not more about security, because now we are running on the user space. The harm you could do is to self harm, really, like not like a system wide harm is very seldom. It's non-existent even. But if you're going to randomly do something without knowing what it does, that's not the place where you start containers. Abdurrahman, do you have any more comments about these things? When to use and when not to use?
I think you covered it, good Sabry. Maybe to sum this up, if there is a recipe for installing the software natively on the system, like easy build, or if you have it as a module, you don't need to use containers. You use containers when you need them. It means you don't have the recipe for the system, or you don't have it installed already as a module. I think you're muted, Sabry.
Thank you. Yeah. So there was a comment about feedback that when we talk about something system specific, like Saga specific, from specific, Betsy specific, please give a heads up. So I'm going to give you that heads up. Today, what we're going to talk about, the exact things that we're going to type in, it will work on all systems. Only thing is there might be slight differences in versions. Let's log into, if you remember the SSH login that we discussed last 2 days, right? You go to from, right? You are in from. The command I'm going to use is Singularity version, to find out whether Singularity installed and what version it is. I will clear the screen so it will go to the top, so it will more clearer for you. Singularity version. So the version installed on from is 3.8.0 something, but it's for the Red Hat 7, which is also the basis for the CentOS 7. Today, the exercises I would do on Saga. some more details that Radavan also talked about yesterday. Here I'm not going to mention my username because it's already the username I'm using on my computer. Let's try on Saga. Okay, so please log into your system that you're going to follow the things I'm going to type. Saga from Obetsi. All the commands I'm going to talk would work on all the versions that we have on HPC systems. Log into your HPC system if you're going to follow. Like if you're just going to watch me, that's fine. People who are going to type along, go and check whether the Singularity is working and give a thumbs up if it's working. If you're not going to check, let's say if you're just going to watch me talking, that's also give a thumbs up. Or yeah, so then I can move on. So then I would know that everybody is okay. People who tested it, thumbs up. People who are not going to test it, also thumbs up. People who no reaction means that they have some issue. So that's my okay. Maybe we'll do the let's see what are the I can see my reactions here. So is a thumbs up going down immediately?
Yeah, it's a thumbs up, going up and down in between. I see 7 now, 8.
Yeah, is there another reaction? Okay, so there's this green reaction. That's the best one. Yes.
So the reaction is like, can you explain the reactions, Sabry? So you can find it bottom of your Zoom, that reactions, and there you can find the thumbs up or green.
Okay, more or less, I think I saw this time. Next time when I try to do a survey, I'll be more specific. Sorry about that confusion. So I think you're already on HPC system, one of the systems, and check Singularity. If you face any difficulty, like an error that you couldn't figure out yourself by following what I do, give a that red cross sign. Let's see the chat. They are showing something. What is a thumbs up? Okay, sorry. So in the chat, can somebody explain this okay and no thing? Because the setup I have when I'm sharing the screen is not the same as the users. Then where to find the images? Usually when you have to use a container, that means that you have landed on a web page or a GitHub repository that says we offer containers as a solution for you. So you have this container, and more often than not, that container would be a Docker container. It's because that's the most popular and sort of like the fundamental part of this content technology. Let's see if you another case would be that you would actually want to find something that works as a container. In that case, you could go to a place like Docker Hub, right? Docker Hub and search for it. Let's say SAM tools. What are the containers that provide SAM tools? So there'll be hundreds of containers. TensorFlow. What are the containers that supports TensorFlow? So you could go and look for it. So that's Docker is one place. And also you could go to Singularity Hub. So these are two different container technology that we are talking about. So the as you are not discussing deep into what container technology is, I'll be doing this in a brief way. So the Singularity is more suited for HPC. Docker is more suited for a place where you have root access. So it's not that you can't run Docker in other ways, but Singularity is more suited for the HPC system. That's why we have it. But this program Singularity can use Docker containers. And there are like specific places like biocontainers. People have built biological workflows and tools that uses using containers, so you can download it and run without installing it on your computer. You know that there are certain pipelines, certain Perl libraries, certain if you think about workflows like Time, if you know what that is, there might be it might be very difficult for you to get it installed. So it provides a container that you could it's ready to use. And also places like NVIDIA, where they distribute these GPU specific containers, which we will talk about tomorrow more. If you try to compile TensorFlow or PyTorch, you will know the pain. It's almost impossible unless we have like a very good procedure for that. So we have compiled certain versions of PyTorch and TensorFlow and so on and so forth on HPC system, optimized for our system using our system libraries, optimized for the GPUs we have. But there might be cases that a new version comes, new TensorFlow version, which is not there on our system. That will take some time for us to develop a recipe for that, to how to install it. Then you could directly get the container. So then that is where you find it. So you could use actually search function from the container tool itself, from the command line. I'm not going to show that here because the scenario, the use case we are going to talk about is that you found a container somewhere that you have to bring it down and run it on our systems. So before we go to this, how to sort of get it to our HPC systems, I'm going to talk about two use cases that we have described slightly below. A user want to use different version of TensorFlow than what we have, like very very specific case. Let's see module. A TensorFlow is a sort of like a Python package that used for the machine learning stuff. Jürgen, are you available on mic?
Yes.
Yes. Are we going to talk anything about very specific packages tomorrow, like TensorFlow or anything, or is it?
No. Tomorrow we'll just go high level into GPUs.
High level into GPUs. Okay. So you have installed this TensorFlow, for example, 2.4.1 on our system. And let's say, Jürgen, you're on first line and somebody asks, I want to use TensorFlow 2.6. What would be your response?
Please no.
Okay. So I like the please part. The thing is that the recipe is not ready yet, right? So let's say somebody really want to, they were in a conference and somebody were talking something big about 2.4.6 going to save babies or something. No, you must try it. Then what you would do is the TensorFlow site, they provide a container that you could bring it down to a HP system and test it out. No need to install anything, but it's in Docker, if you can see there. So we'll come to that. Another case would be a user needs a software that only runs on Ubuntu, for example. Is there any specific example, if you have any specific example that you have encountered this? Because bio software, they more or less, like more often I should say, they are not built for CentOS or the operating systems they are running, maybe for Ubuntu, right? So then you might we can't install Ubuntu on our system, so you might want to use a container instance. So this very specific example uses a BioPerl library, which we can't sort of compile on our system, very difficult. So it works very easily, that version on Ubuntu. Okay, so now we are going to go on for some hands-on. What we are going to do in this exercise is to get this hello world zip file. So hello world zip file, hello world container, and create this hello world file. So Abdurrahman, do you have any comments about this file that we are going to create, .zip? What does it mean?
SIF is a Singularity image format, and this is an image format that is Singularity is using. It is not exactly the same as Docker because Docker used the OSI standard. SIF format is a OSI is for Open Container Initiative, and this is a standard. SIF is OSI compatible, but it is not OSI. So the structure is a bit different from Docker, but it is somehow compatible. Yeah.
Yes. So I'm going to pull this from Singularity Hub, the one I showed you, one of the places I showed you before. Probably I have closed it. Yes, here. I'm going to pull it. I'm going to sort of download it to my computer. So the command to use is, let me move this down a little bit so I can show you more. Let me arrange this first a little bit. Yes. Yeah. So I can show you that what I'm typing. Before we go to this place, that I would recommend not to do it on the home directory, because the files might be bigger. When you download, when you test, you might not use the same container, same container image that I'm going to download, and there might be quota issues. To avoid any unnecessary like issues not related to what we are going to talk, I'm going to go into this folder. Most of you would have access to this NN9987 folder. If you don't, use the command called projects to find out which projects you have access to and go to one of those folders. So I'm going to go into the site folder. I'm going to create a folder with my name. Sorry, I already created that one, so I'm going to use that. Let's see anything in there. Okay, no containers. I'm going to clear it so I'll get some more space. So this cd command, I think you're more familiar with it now, how to change to directories. If not, maybe somebody could help in the HackMD to find out. So this is the place, there are no files. I'm going to issue the command singularity pull, pull. I'm going to give a name for the file that I'm going to download as hello world.sif, right? And then this URL. So I'm going to download it from Singularity Hub.
Sabry, you didn't type .sif, you added -sif.
Okay, let me delete that file. Ergan, like let's say if I had that, what sort of if you didn't notice that and I continue working, what are the issues that I would have had?
You probably actually wouldn't have any problems since the file ending doesn't really matter, but it's good to be consistent.
Thank you, Ergan, and thank you for keep an eye on what we do. So this is a hello world file. We can use a command file, Unix command, to see. I'll make it a little bit smaller so it'll be more. I'll have a little more real estate for this. So it's a data file, Unix says. You know, it's a data file for Unix. So this file contains the operating systems, the operating system, and all the software needed for that container to work. And if you're pulling it from Docker, for example, let's say you can use the same command. Maybe I can have a little more space here on my terminal. If I reduce my this prompt. Okay. If it's the same thing as here, that the pool and the name you specified, if you want to pull it from Docker content, Docker hub, here I see the alpine.sif, and then I have this. It's a Unix image. You would do that here. And for you, if you remember, if you notice before, it says cached image, because if you already done it, there's some cache which makes the download faster. So you might not see this, but instead you will see something like this when you do this, because then it's downloading the entire thing. It is the same thing with like other place I show. You have to get the correct URL, the place download, and you have to specify which hosting we're going to use. If you use Docker, it's going to get from the Docker, and it should be there in the Docker. Like if you remember here, where's the Docker hub? Okay, so it should that container should be already there on Docker in order for this to work. So if you're going to search Alpine, the latest version, it will be there on the repository. So there I have now 2 files, and then you could also issue the command and download it. If you see if you face any errors, please respond, or you could even ask directly. Best is the HackMD. I think someone has placed, Dania, is that correct, that there's some good information about how to react?
Yeah, Thomas added an image, Zoom image on HackMD. So
thank you, Thomas. Yes, thank you so much. So you could download one of this image. You can follow one of these examples. Sorry. Or you could go to Docker Hub or NVIDIA or like bio containers, and you could download one of those images. It's up to you, but maybe it's easier for you to follow the examples as it is, learn how to do it, and then come back later on. So while that's the downloading taking place, there are 2 things that as like a newcomer that you would see. You would see the command exec and run. Execute and run. It's more or less sounds similar, right? But there are instances that we use exec. There are instances we use run. So when you use the command execute, it runs a command within the container. But if you use the command run, that means there's something predefined inside the container that you would run. We would see that example in a moment. Okay, let's see. Well, let's see that example now. Singularity exec, the hello world that we downloaded now, and I'm going to cat a file called Singularity, right? Just to make sure that to show you something, if I type cat Singularity here, there's no file. So I'm going to see a file inside the container. So here you see it's no such file, but if I ask from the container itself, it says there's a file, a bash script that runs this row.sh. So the default behavior of that container is to run that file. So how to run the default behavior? Instead of exec, use the run, and then it'll run this file. So that is to use the default behavior of the container is to run, and exec is to execute a command using something inside the container. To give another idea that I missed here, the short miss, the operating system that we have on our systems, cat OS, etc OS. I will use the head command, or maybe a grep to see the version. Maybe it's easier name. Okay, I'm going to use the command grep name that we saw slightly here. So it's CentOS. If I do the same thing on the container, exec, let's say OS release grep, okay, it would say Ubuntu. So we have 2 operating systems there, so we can do that. try to do it in one of your systems that you are logged in. Let me check the chat. Yeah, HackMD. Check the HackMD a little bit. Okay, thank you for pasting more information about what is a container, what is a kernel. Yeah, I think it's all going good, I think. But if you don't agree, please respond, then I could change. Next is that let's see, there are some files that you want to access through a container. So here a slight a small warning that next is that I'm going to run a job as a job script, but I'm going to hop over a little bit to tell you to the last, go to the last part to tell you how to access a file, then come to the job script, because if there's a question while the job script running, can I access my files? It's easier for us to answer without jumping back and forth. Let's say this is the folder I am in. I'm going to create a folder called data. So if there's anything on HackMD that I should stop and pay attention, please, our colleagues, let me know.
Yes, Sabry, could you explain the difference between execute and run on Singularity? Maybe a little bit more.
Okay.
The last question on HackMD.
Yes. So if you use the command run, that will do something that is predefined inside the container, and the container would terminate. Like, it is to run something predefined inside the container. Exec is to use the container to run something. For that, I think it's best that I give an example. Let's see. Is there an example that would fail with run? Let's see. Okay, so this BioPerl example, for example, right? Let's say I'm going to pull that image. It's being pulled. Abdurrahman, do you want to add something while this I'm doing this about this run and exec?
Yeah, run is a shortcut for exec, if we can call it like this. So exec is you get the container or file system and you run a specific command in it, execute a command inside the container. While run, you run the default command.
Default command. Okay. So let's see what the Singularity file contains on this container. Okay, so it has it's setting the Perl path. I'll make this a little bigger. Yeah, it refines some arguments. Okay, let's run. So when I run this, it might probably fail, but let's hope it fails so I can explain. If it will not fail, then you have to find another example. Okay, sorry, that's not what I want to do. It went to the interactive prompt. How can I make this fail? Okay, let's just look at that file again. So in this Singularity file, it has defined what to do if I run it. If I want to use the Perl inside that container in order for me to run something I have, let's say I have a Perl script. Okay, let's do the Python one. Let's do the Python one. That's more. Do you have okay, let's pull this where is the Docker Singularity? Okay, TensorFlow. Okay, so then TensorFlow, I have some Python code inside. Maybe I can use that one as an example. until that okay, it's downloaded. Let's see. I didn't specify a name. Let's see what file it created. So it created a file called TensorFlow because I didn't specify a name. Singularity, run. Here, is there a specific Python command that I could run? Okay, let's try to run TensorFlow. Let's see what this will happen. So I want to run I want to see what the OS release is, but I'm using the run command instead. So it's printing this. Then if I have a exec, so that's also not a good example. Let me come back to an example that run and exec would not be the same. If I can't find something today, I will find let's see something tomorrow. So there are, if the predefined command would always run regardless of what you specify, but in this case it's sort of defaulting to something, so it runs anyway. So I want to find something failing, but I think I can think of something before the end of the lessons. Let's see. First I will go for the data, how to access data. I'm going to create a folder called data, and I'm going to create a file, input.txt 1 2 3 4. So I have this file. So I want to access this file from Singularity. So I'm going to go to the place where it's explained. So I will follow more or less the same thing. So I have input text. Okay, same file name. That's good. So if I come here and I want to display the first two letters of the first two lines of the file, head minus n2, sorry, data input.text. So it prints. If I want to do it, if I want to access this data from a Singularity container, let's see how I can do it. Singularity exec hello world. I'm going to use the same command. Let's hope this one fails. Data dot input dot txt. Yes, very good. So although the file is here, let's say ls, it's here, it didn't run it. Then I'm going to show something more. I'm going to, instead of head, instead of accessing this specific file, to show you another behavior, I'm going to do a ls minus lh, and it's going to print something actually. Stig, are you around on mic?
Yes.
Yeah. So why I can't access the file here? And do you have any explanation? But I could list the files. It was, yeah.
So what files are these? Do you have in your home directory? I guess you have a directory called data as well.
Yes, very good point, Stig. So that's what I want to say. When you start a container like this, with our setup on our HP system, the home directory will be mounted. So I created this directory on purpose. That also has, I have a directory on the home directory. So just because something doesn't throw an error, it doesn't mean that the container had access to that directory. So you have to explicitly say that. Then I have shown something more. Okay, the full path. Let's say if I give the full path. Again, this should fail, hopefully. It can't find it. So how we could give this? How could we give access to the this certain folder without this ambiguity. You know, there might be a same folder name data on my home directory. I don't want to access this one. I don't want to access that one. I want to access the home directory I have here. Not the home directory, the data directory I have here on this folder. So in order to do that, we use a command called bind. The commands I'm going to type is exactly as here it's included. Singularity, use the exec, and I do the bind and the path for that directory, then a colon, then I could specify a place inside the container that I want it. To make it more like less ambiguous, I'm going to call this directory 2, right? So I will not because if I to avoid that directory I have on my home directory, and then hello. Do I have the, am I in the correct directory? I'm inside the data directory, so I'm going to go one level back so I can have access to the Singularity file easy. Hello world, then ls lh data 2. Then it has my input file. I could check the first 2 lines of the input file, input.txt. it will print, but if you avoid this slash, then it will not work, because that is where we mounted. With that information, let's see how would we call this inside a job. How can we submit a job with this information? If you remember the let's find a good example. So what we have is ls. So still I'm thinking about that a container that causes an error that I'll come back a little later. I'm going to create a job file, Singularity test.sh, or like slurm, or whatever you want to call it. I'm going to create the job script that we all have been doing, bin bash, and I want sbatch. My account, okay, reservation, or it's only valid for today, so I'll use that as well. In tasks 1, because I'm just going to do a test, I'm going to do a mem equals 1 GB and maybe a job name, Singularity test.
Just a heads up, Sabry, you have typos in both account names. But
Okay.
maybe that was deliberate.
I hope it was, but it was not, sorry. Was it the 887? 88? Oh. Well, what was the project account?
Yeah, it should be 87.
87. To make things a little simpler, I'm going to issue a command that I used before. This command, if you remember, the to view the operating system. Let's do it with the hello world. So I want to see the operating system of what's inside the container, which we could of course run a different command as well if you want, but I'm going to, for the demonstration purposes, I'm going to do that. Host is the machine that we are logged in, where the container is going to run. Host OS. That I'm going to do it without the Singularity. Then container OS. Then they should print. So if you see, remember I didn't load any modules because all the Singularity is installed on login nodes and also on compute nodes. So it's everywhere. So you don't have to load anything, and you can exactly follow what you did on the login node. So this is to demonstrate what you would need on job script. So these tasks and end nodes and memory, you have to adopt according to the container that you're going to run. Let's see how it looks like. This is the one. So let's submit that. Yes, batch, if you remember. Okay. I forgot to mention something. Do you notice what I forgot to mention? It is the time, how much time I need. Dispatch. Let's give it about 5 minutes. Let's submit again. Let's see the queue. Oh, it's ended already. And with the same job ID, it has created this log file. Let's have a look. Hope it's okay. Let's if it's error, that's also educational. So this is the this is what is printed, the host OS. Okay, so there's a mistake in my job script. I'll show it. This one I didn't print, so maybe I could echo that. Echo host. So I'll have a better idea of which one is host and which one is Singularity. Divide it. Because everything was printed together, so it was difficult to figure out what was what. Container OS. Yeah, let's run this again. I'm going to remove this log file to reduce any confusion that might arise. Because it was so fast, it should just run sq -u my user. It's done. A new file is created here. Slum less. This is the host OS, which is CentOS 7, divided by that line I printed, and then the container OS, and the job, how much time it took, and etc. etc. So Danya, we were planning to stop at 10:20, right? Not 10.
Yes, 10:20. Yeah.
Yes. Yes. So I more or less I showed what's in this material. So we'll try together. So I want everybody to, if you want to try, we'll try together, and there might be some issues that we might see that we could discuss. So please go ahead and try these things. Try to find a container that might be of interest to you, and also notice that, for example, if you go to Docker, sorry, the TensorFlow Docker image, there would be a very specific Docker command to run. You'll pull it, and then you have to run it as Jupyter Notebook. But you don't have to like the copy paste might not work, because the way we are going to use might not be the same. So instead of Docker, you could use Singularity. And here that person who's downloaded is running this command to find the Python version. So we could check that at the end. So copy pasting from a site might not work. You have to adopt a little bit using this concept: exec, run, bind. If you have that understanding, you could actually interpret, okay, so this is going to run with Jupyter, but I could still use the TensorFlow inside for my calculations. Okay, go ahead and try. And if you need breakout rooms, please inform us so we could come and help. And if you face any issues that you think are interesting for everybody, we could discuss openly. Yes. Good luck. Could you show us how to use Singularity pool Docker for Plasmid Finder tool? Okay, so specific tools. Let's see what it is about. Go to Docker. So there are several Plasmid Finder COSEC. The person who asked the question, do you see the specific one? Is there a specific one here that you want to use, or is anything is okay? Who asked that question? Maybe I'll use this one or this one. Okay, let's try it. So it says to pull like this. The pull command is already there. And if
the person answered it, Sabry, on the HackMD. Which one? Genome. Yeah.
Okay, second please. Okay, second. I'll close this extra one so I'll have more overview of what I do. Yeah. So the command is here. That person has given some extra information on how to use this. Maybe let's see what this software does. Yeah. So he the person asked to run it with an entry point test sh and Plasmid Finder. If I paste this image, copy paste it from the site, it would fail because I don't have Docker. So what I can do is I can use Singularity instead. Singularity pool. I use Docker in front to say it's Docker and pull it. Right? So that is the first difference. Can't copy paste, but you have to sort of use the knowledge you have to slightly modify it. Then it has some packages. Let's see. Test sh and Plasmid Finder. Okay. So this Plasmid Finder software should be inside this content. Let it download. Okay. Singularity exec. Let's see what's in the Plasmid file. What's the default behavior is. Singular. It yeah, entry point is this. Okay, so then I could run actually this one and see what it does. It should print maybe the Plasmid Finder version. Let's see, maybe it's okay, no input file provided. What kind of input file does it need? Okay, let's give a random file and see. Data input. Then it gives the usage. So the usage is you need to have an input file with an I. Okay. Good point, because it's not, it doesn't exist because I didn't bind it. Bind, let's find the path first. pwd data to data to data to. I forgot a slash in the beginning. Input file must be in FASTQ or FAST format. Okay. I'm just feeling my way around, because this is these errors are related to the usage of the software, not the Singularity, how to use Singularity itself. Test FASTA. Okay, it's a plasmid. Yeah, okay. Test FASTA. Yeah, it gives some. Yeah, maybe it makes sense to you. The it's there's with this information. Sorry, the FASTA test. This sequence is not part of a plasmid, so that's what the software says. But how to run the software is like this. You instead of directly cloning the plasmid finder, you have these things in front in order to run it with Singularity and to provide access to data. Let's see what was the response for that. So this thank you means you found. Does it make sense? Did I miss anything? Thank you means I think it's a good thing, right? So thank you for trying to show it, or thank you that you know how to use it now. So this one here is where to pull. Use the project directory to pulling. But if it is a very temporary thing, you're going to use it only once. Use it to user space, which is cluster work users your username. But project is like a general place, because the home directory, it might fill up if you download too many things. It's a very good answer here typed already. Singularity file. Yeah, let's see the answer here. Yeah, you don't need to transfer it back. And sorry, do the pull not from the job but from the login node. The reason is, if it is a big image, until it pulls down and create the zip file, the cluster would be idle. There's no processing happening, so we don't want to block it. But if it's a very small file and you want to download it to a scratch space, do your processing and get rid of it, that's fine. Inside the job even, it's okay. But usually I do that on my login node, so I know if there's an error during download, some mismatch tags, for example. The tag is the exact name for the container. The Singularity document, yeah, it's pasted. It's already there on the document. Yes. Installation and configuration, I said I'm not going to follow here, but those are different topics and also important topics. But here what you're talking about is how to get started using containers on HPC systems. Yes. Yes, so this is the command. Thank you for pasting it here. Let me find a good example of that very specific question earlier raised. Exec versus run. What are the most popular images on Docker? Let me open it up in another terminal and see. Okay. This seems to be a very popular image. Oh, okay. So there's this image which pulls down. I don't know what it does, which I should do without like knowing what it does. Should download it. Pull.
Sabri, do you have 4 more minutes? Maybe you can ask anyone have any problem to try this also.
Yes, go. I'll answer the questions instead.
Sabry,
go ahead.
Sabry, thank you a lot. It was my question regarding the Plasmid Finder.
Okay.
I was fighting with the Docker since probably 1 week. Yeah, because they have some problems to provide by Conda and so on. That's the reason. I hate Dockers, and thank you a lot. Thank you a lot for showing us.
Okay, you're welcome.
It works.
It works good.
Yes.
So Sabri,
Go ahead.
I have so one comment. I see you are using a lot of cached images here, and
Yes.
you have already pointed on moving all this stuff into a project area in order not to fill up your home. But if you see here on the comment, so I scroll down again. So
Yes.
yeah, so it says that all your cached images are still under your home. So this is something to keep in mind.
Let's see how much it is. So, Stig, is there a way to redirect Singularity cache or avoid caching?
Yes, there is an option
Can you?
in the Singularity pull, but I don't have it.
It's
Yes,
a
top of my
dash
head.
disable cache.
And there's also something to redirect it to something else. So.
Something like this, Jürgen? Okay,
Yes, that should work.
Okay, let's remove this cache and see whether that actually. So I have about 5 gigabytes, the 3 gigabytes here on Singularity. Then let's try Jürgen's trick. Oh, okay. Remove that. Lol. Okay, it's downloading. Let's see the size of my. Very good, Jürgen. So that actually solves that. So if I use the disable cache, it doesn't fill up my home directory. Thank you, Stig and Jürgen, for noticing that something that's very important, because even users might not see the dot file if they do like ls.
Yeah, could you add this on the HackMD Jürgen and Stig? That would be nice to have there as well as a comment.
It's already commented.
Yeah,
Somebody
good.
else asked.
Thank you.
Okay, 2 minutes. Sec. So in this container, I want to see the operating system, and it will print like this. Let's see with the run. Okay, So the run, it just ignored here. This is a good content that actually failed, that this is something I want to do it. So here they have defined something very something default. So it's sort of ignoring what's here. So in that case, regardless of what you provide, it will run the same thing. It's some cow giving you advice. You should emulate your heroes. Yeah, sounds terrible advice, but still, yeah. But if you want to get that behavior of executing your command instead of the default, you should do the exec. So that is I think shows the main difference between exec and run. Other containers are very sort of, they thought about it, those a lot of mixing this, so they actually didn't throw their. Okay, Danya, over to you.
Yeah, thank you, Sabry.